Objectives 41 through 44 talks about the power rule. I want to start off by just recapping what we've learned so far in this unit. If I have a to the n, this is just a normal exponent. What this means is we multiply a together by itself n times. So an example of that, if I have 3 to the 5th, that's the same as 3 times itself 5 times. So 3 times 3 times 3 times 3 times 3. If you plug that into your calculator, you'll find that that's equal to 243. We also learned that anything to the 0 exponent is 1. We learned that negative exponents flip the fraction, so if I have c to the negative 2, we can rewrite that using a positive exponent and flipping the fraction. So we have 1 over c to the positive 2. We also know that by the product rule that a to the m times a to the n, see the bases of these are the same, is the same as the sum of the exponents, or a to the m plus n. The quotient rule is quite similar. We've got d to the x over d to the y. This would be the difference of the exponents, so d to the x minus y. The power rule that we're learning today it follows from the product rule. Suppose I have a to the 4th to the 5th. You may recognize that we have a base of a raised to the power of 4, and then that's all raised to the power of 5. Because of the way that we have grouped this, we can also think of this as the base is a to the 4th and the power is 5. So we can rewrite this as a to the 4th times itself 5 times. So a to the 4th times 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 a to the 4th. Well, what we know from our product rule, we can just take all of the exponents and add them up. So 4 plus 4 plus 4 plus 4 plus 4 gives us a to the 20th. So how can we get from a to the 4th to the 5th to a to the 20th? Well, it's the same as a to the 4th times 5. So the power rule tells us that if we have a power raised to another power, we can just multiply those powers. Let's practice. Here we have r to the 4th to the 2nd power. So we can take this as r to the 4th times itself twice. That's where we get that squared. We're taking the base, r to the 4th, times itself twice. We can add the exponents, and we'll have r to the 4 plus 4, and we get r to the 8th. If you choose to evaluate this using the power rule, or simplify this using the power rule, you may also recognize that this is r to the 4 times 2, which gets you r to the 8th. Either approach is fine. You may use either. Looking at this, we have 2 squared to the 3rd power. So this is 2 cubed times 2 squared times 2 squared times 2 squared. 2 squared times itself 3 times, or 2 to the 2 plus 2 plus 2, which is 2 to the 6th. You may also have recognized that this is 2 to the 2 times 3, or 2 to the 6th. Here we have y to the 4th to the negative 9th. So we have y to the 4 times negative 9. 4 times negative 9 is negative 36. So we have y to the negative 36. Again, we don't want any negative exponents in our solution. So we can take this and flip the fraction. So we have 1 over y to the positive 36. And that's our solution. Here we have 4 to the negative 2 squared. So we can write this as 4 to the negative 2 times positive 2, or 4 to the negative 4, which is 1 over 4 to the 4th, the positive 4, If we evaluate that using our calculator, we can get 1 over 256. Here we have h to the 9 times 3, or h to the 27. Here we have c to the negative 6 times negative 4. We have c to the positive 24. A negative times a negative is a positive. Okay. A few things to keep in mind. We can also use the power rule using multiple factors inside of the parentheses. Whenever we do that, we want to make sure you multiply the outer exponent to each inner exponent. So don't forget, any factor in there needs to be multiplied with the exponent. Make sure you multiply the outer exponent to each inner exponent. A hint: if there is no exponent, so if no exponent is written, then it is 1. Let's take a look at this. Here we have r to the 4th, s to the 4th, all raised to the 4th power. This is the same as r to the 4 times 4 times s to the 4 times 4. We can distribute that exponent. So here we have r to the 16th, s to the 16th. That's our solution. Here, again, we distribute the outer exponent to every inner exponent. So we have a to the 2 times 3, b to the negative 6 times 3. So we have a to the 6th, b to the negative 18, and we want to get rid of that negative exponent. So we set up our fraction bar. Does the a have a negative exponent? No. So that stays where it is on the top. Does the b have a negative exponent? Yes. So we'll flip it down to the bottom. And then we use the positive exponent. And that is our solution. Here, one of the biggest things that students miss is 2 is also a factor. There is no exponent written, so you can assume that it is 1. We want to distribute the outer exponent to that as well. So we have 2 to the 1 times 7, y to the 2 times 7, and z to the 3 times 7. 2 times 1 to the 7 is 2 to the 7th, y to the 14th, z to the 21. Now, we can evaluate 2 to the 7th. 2 to the 7th is 128, and then we'll bring down the rest. And that is our solution. You can also do that when your base is a fraction. So similarly, we want to multiply your outer exponent to each inner exponent. Even if it's on the bottom. Multiply your outer exponent to each inner exponent, even if it's on the bottom. So looking at this here, we're going to multiply our exponent here, but we're also going to multiply it to the exponent on the bottom in the denominator. So we have m to the 3 times 2 over n to the 3 times 2. So m to the 3 times 2 is m to the 6th over n to the 6th. This one here, there's no exponent written here, so remember we can write a 1 as the exponent. and then we can distribute like normal. So we have 1 to the 1 times 3, and we have r to the 2 times 3. 1 to the 1 times 3 is 1 to the 3 over r to the 6th. Well, we can evaluate this here. 1 to the 3, or 1 cubed, is just 1. So we have 1 over r to the 6th. And lastly, our exponent here is 1. We can distribute, and we get 2 to the 1 times 3 over d to the negative 4 times 3. We get 2 to the 3rd, and d to the negative 12. Now, negative exponents, remember, it just means flip the fraction. So if it's in the numerator, it goes to the denominator. If it's in the denominator, it'll go to the numerator. So looking at this here, we've got a negative exponent, so we've got to deal with that. We've got to flip it. So we've got 2 cubed. That's just a positive exponent. That stays where it's at. D to the negative 12, the negative exponent just says flip it. So we'll move it to the top and then use its positive exponent. 2 cubed we can evaluate, so we get 8, and then d to the 12. And that is our solution. This has been objectives 41 through 44.